equations and formulas. So the first thing in this lesson is there's a lot of formulas to know. So each of these formulas help us calculate certain aspects of, shapes, dimensions, measurements, things like that. So we have all of our formulas for area, circumference, volume, and perimeter. So for all of these, I'm going to go over them with you during class. So don't worry about taking notes on any of these right now. The main focus of today's lesson is literal equations. So literal equations are an equation that has two or more variables. Okay, so that means that we'll have multiple unknowns. For example, a literal equation could be xy equals x times y. This is a literal equation because we don't know our values for both of our variables, x and y. So we'll go over the first example here. Xy equals 8, solve for y. So the thing with literal equations is when we solve these equations, we won't always get a constant as our solution. Instead, we will get an equation as our solution. So if we want to solve for y, we need to think about what's happening between x and y right now. As you can see just above here, x is being multiplied to y. So if we want to solve for y, we have to use our inverse operations to divide x from both sides. All right, from there, our x's are going to cancel out on my left side here, leaving me with y equals 8 over x, which will be my final solution for this one. Like I said, your final solutions will be equations for these type of questions. All right, moving on to page number 2. Let's do another example, and then I'll leave the last one for class. So if I have w minus 8 equals h, and we're asked to solve for w, we need to remove this negative 8 from our left side. So right now, that 8 is being subtracted from w, so our inverse operation would be to add 8 to both sides. By doing this, our negative 8 cancels, leaving us with w equals h plus 8, which will be my final solution for this one. All right, like I said, I am going to leave that next example for class. I will do this middle example though. So in this example, it wants us to solve the equation 4 equals 2m minus 5n for m, then find the values for m when n is those various values. So if we want to solve for m, we need to get rid of our minus 5n from the right side. So we can do that by adding 5n to both sides. And that's going to get me the equation. Oops, I forgot an n there. That'll get me the equation 4 plus 5n equals 2m. But in this scenario, m still isn't by itself. So right now, we have 2 times m. So in order to undo our multiplication, let's divide 2 from both sides. So for this one, my final equation is going to be 4 plus 5n all over 2 equals m. And I can leave my final solution just like that. But this question takes it one step further. It wants us to find the values for m when n equals -2, 0, and +2. So we can do that by using substitution. So let's start by substituting -2. So I have 4 plus 5 times -2 all over 2, which equals m. So let's calculate this. Order of operations, multiplication comes first. So 4 plus 5 times negative 2, which is negative 10, all over 2. Now I'm going to go ahead and simplify my numerator. 4 plus negative 10, which gives me negative 6. And then finally, negative 6 divided by 2 gives me negative 3, which negative 3 would be my value for m when n is negative 2. Okay, I'm going to repeat the process for my other values. 4 plus 5 times 0 over 2. 5 times 0 gives me 0. So that's going to give me 4 plus 0 over 2, which simplifies to 4 halves, which equals 2. Now do the same with positive 2. 4 plus 5 times positive 2 over 2. 5 times 2 is going to give me a positive 10. 4 plus 10 gives me 14. And then 14 divided by 2 gives me 7. So those would be my answers when we assign a value to n. All right, next we have rewriting literal equations with only variables. We will save that one for class together. But let's go over these last two examples just to see a couple more cases. So for my first example here, I have 2x minus xy equals 8. So we are trying to solve for y in this case. And when you have multiple variables, it is super helpful to highlight or star the variable you're trying to solve for. So if we're trying to solve for y, we need to use reverse PEMDAS. So the first thing I want to remove is this 2x. So I'm going to start by subtracting 2x from both sides. Okay, that will give me negative xy equals negative 2x plus 8. Or you could write 8 plus negative 2x. Both are the same. Now we're still trying to solve for y, so we need to get rid of our coefficient. For this one, my coefficient is negative x, so I'm going to divide negative x from both sides. Okay, from here, my solution would be y equals negative 2x plus 8 all over negative x. In a case like this, this fraction could be simplified, but since our main focus is literal equations, I am okay if you leave it as that. Okay, in our second equation, we have a equals pi r squared, which is one of the formulas we will talk about in class together. So right now we're trying to solve for r. Okay, so reverse PEMDAS, we are not adding or subtracting anything to r, but we are multiplying. Right now, pi is being multiplied to r, so let's start by dividing both sides by pi. Okay, and although pi does have a numeric value, we will just leave it as pi for this example. So dividing pi, I would have a over pi equals r squared. Anytime you have a variable squared and you want to undo the operation, then you're just going to use a square root. So right now, I'm going to take the square root of both sides, which will leave me with the square root of a over pi equals r, which is my final answer for this one. Once again, you could simplify this if you would like to, yet I would like if you would just leave it as is. Okay, so for this lesson, we do have two more examples. I want you guys to try both of these on your own and then come to class with any questions you have and we'll take a look at them. All right, thanks for watching.